Hello and welcome to this webinar on network performance management for cloud and digital operations, sponsored by Kentik. Today we'll be looking at how changes in network traffic flows due to the shift to cloud, distributed applications, and digital business in general has upended the traditional approach to network performance monitoring and how NPM is evolving to handle these new realities. Today our presenter is Jim Fry. He's Vice President of Strategic Alliances at Kentik, and prior to Kentik, Jim was Vice President of Research at the analyst firm Enterprise Management Associates. And so from that background, he brings a ton of perspective to share with us, on top of the experience he got when he spent time in executive roles at NetScout and Micromuse. So a couple of logistical notes. There is a Q&A panel where you can enter questions, which we'll get to at the end of the presentation. I think with that, I'll hand things over to you, Jim.
Great, thanks, Alex, and welcome everyone. Thanks for joining us. I think this is a very timely topic. There's some really interesting challenges out there, and I'd like to take the time here to share a little bit about what we've seen and what we think are some ways forward. What I'm going to talk about today for you here is we have to do a little bit of level set and define what we mean by network performance management, just so we're all on the same page. Then we're going to talk about why is this hard in these sort of next generation newer environments that we're dealing with the entree of cloud and digital business architectures. And then we'll talk about what we think are 5 keys to success for solving some of those challenges. And we'll wrap up a little bit of a view on how we're dealing with that at Kentik. And then we'll finish up with some Q&A. So jumping right in. So defining NPM, it's important to understand here at a very high level, we're talking about going beyond just recognizing is the network available and functional, and more to how well is it doing its job. That's really what we're trying to figure out with NPM. And we're trying to figure out if the network is doing what is expected for delivering applications and services. And that's slightly different than just understanding is the network there and available. So some things that you would see as typical activity measures on the network are not necessarily directly relevant to NPM. So this is not just looking at the traffic volumes or the counters or stats that you can get from interfaces, or even the kind of data you get in logs and events. Those can be helpful in understanding network activity and some forms, very simple forms of network performance, really just on the side of utilization. But what we're really looking at and talking about here is moving to another type of metric. And metrics such as round trip time, such as out of order packets, retransmits, fragments, these sorts of measures that tell you not just is the network doing its job, but how well is the network doing its job. And specifically, what role is the network playing when it comes to the bigger question, which is end user or customer experience. So ideally, when you put an NPM sort of solution in place, not only can you get these understanded new metrics about what's going on with the network, but you have a way to tie it back to those applications and services that you're trying to deliver or that are being delivered over the network, because that's the point that ties you to the ultimate business goals of improving and protecting network performance. So it's also useful and I think really important for our discussion today to talk about a little bit of the techniques and technologies related to NPM. So there are 2 kind of primary categories of data sources. There's the synthetic type data that you can generate by setting up robots that will send examples of traffic through the network and then see what happens to it and calculate the metrics that we were talking about. And then there's passive observation of real actual traffic. And that's mostly done by either looking at packets that are going across the network or generating flow records. But even frankly, the flow records themselves are simply summaries of what packets have been going across the network. So ultimately, all of these techniques both of those techniques come back down to understanding what's happening at the packet level. They are just then transmitted and inspected in a slightly different way. Logs is also a way to get some information about network performance, but you have to be fortunate enough to have log sources that will actually give you those sorts of discrete performance metrics. They are out there, however, they are not common, and it's not something that most people make a primary part of their NPM strategy. The other part of the conversation here with respect to technologies it's good to know about is that there are definitely different types of architectures that are used to deliver NPM tools. The most common, people buy and deploy appliances, connect them to their network. This is the way most packet inspection happens. Direct packet inspection is a means for understanding performance. There are plenty of software-based solutions too that you can download and on whatever server you happen to have handy. That doesn't tend to work as well when you're dealing packet inspection because of the volume and the sort of real-time nature that you're dealing with. The last one I want to point out here, one that's growing, of course, one that Kentik is a bit biased towards, is SaaS. And SaaS is becoming an important way to access technologies that would otherwise be difficult to install and to get levels of functionality that would otherwise be expensive or difficult to achieve. So what is challenging? This is part of the real purpose of the discussion today is to talk about some of the challenges, around network performance management with respect to cloud and digital operations. And I want to start with sort of pulling back a little bit and looking at the 10,000 foot view, because this is important context to think about as we go through this conversation. Remember that the reason we're moving to cloud, the reason why organizations are remaking themselves into digital operations is to achieve business goals. They really want to achieve improved goals of the types are shown here. You want better productivity. You want user and customer experience to improve or be protected. Ultimately, you're trying to generate revenue, unless you're a governmental agency, in which case you're just trying to treat your constituencies well, right? So on the other hand, the operations guys and the engineering guys in the technology team needs to figure out how to do this while operating efficiently. They have to look at cost containment. They have to look at optimize what they have in place, and they got to be quick. So these two need to be both watched, and they will drive these sorts of objectives. Will drive both some of the challenges as well as some of the choices around NPM. Certainly, that goal, the set of goals on the left, is in large part, driving the move to cloud and to digital operations. And some of the ones on the right are as well the cost containment issues, for instance, the speed to market. You can move much more quickly as an organization if you're leveraging cloud than you can if you're trying to build out your own infrastructure. You give up some visibility and control. We're going to talk about that. But it's part of this balance that you always have to maintain. Now, back to the specific problems. We thought actually that one of the Gartner analysts captured this really well in a piece that was put out in May of this year. And it included, it's called Network Performance Monitoring Tools Leave Gaps in Cloud Monitoring. And it stated a few of the sort of major issues that exist. And I think I'm going to share a few of them with you here. One point was that, hey, you're still responsible for performance even if you don't have control of the infrastructure. That's definitely the case when you're dealing with external cloud resources. Another point that Sanjeet made in this report was that, hey, this is really creating a fundamental change in the way that network traffic patterns exist and occur. And that's really creating some gaps that are not well filled by the existing tools. Packet analysis in particular becomes far more difficult when you have a cloud-based environment or any sort of hybrid environment where a part of the packets will be traveling across networks that you do not have direct access to. And so the question of instrumentation becomes difficult. Where are you going to get those traditional measurements? And what this all sort of rolls down into is that it's answering some of the basic questions about where the source of performance issues are based. Where are the root causes? Where are the latencies occurring? It becomes far more difficult if you don't have those, tried and true traditional means for instrumenting and finding this information. So we thought Gartner did a very good job based on the inquiries they do of sort of capturing the current challenge with these environments. So we like to think of this in kind of three parts in terms of the challenge. And first off, you have this instrumentation problem. And the instrumentation problem is when it was all in my own infrastructure, on my own data centers, on my own WAN, in my own network, it was pretty straightforward for me to say, okay, I know where I can go and instrument, put some sort of probe, put some sort of sensor, draw some data from, and it's pretty easy to get the data that I need to do NPM. The problem becomes when you have mixed and hybrid infrastructures. And the fact that even though you can find instrumentation points in these sort of non-owned portions of your infrastructure, you are not going to be able to see the rest of the contextual environment in which those resources are operating. You can't tell what else is going on around it. And this makes it very difficult to understand, can you get the key elements of metrics and measurements that you need? The second problem is the dynamics problem. The digital infrastructures, whether they're internal private cloud or they're hybrid or they're external cloud, they are by definition very dynamic. They've been designed to be this way in order to provide agility for the organization, quick time to market, faster ability for an organization to move and follow opportunity without having to go through lengthy procurement deployment cycles of traditional infrastructure. Well, this means it's moving and changing much more quickly. And therefore, not only do you have a problem with finding a point to instrument, but that point, if you do find it, keeps moving. So it's a constantly changing environment, and it's difficult to keep up with. This is a big problem. The last one is going to be around the scale problem. And the scale problem is, how do you keep up with the fact that you can actually start to create and generate a bunch of new infrastructure very quickly, and then turn it off, by the way. So part of the natural behavior of these digital and cloud environments is this sort of elasticity. Looks like we clipped a few words off this slide, but essentially the whole point is how can you handle and get and maintain the volume of data you need for keeping on top of performance and understanding it. So let's talk about some ways to potentially deal with this and to sort of get our head around how we're going to improve this. So we like to think of it in terms of 5 key points. And they're listed here. We're going to talk about each of them in detail, but basically it has to do with what you look at in terms of traffic. It has to do with finding and figuring the types of technologies that will actually work in these environments. It's about being aware of the broader environment that you're placed in and some of the pieces that you don't necessarily traditionally care about or have cared about in the past. It's about understanding how you're going to manage the data volumes. And finally, and this is really important too, as part of this whole new sort of strategy and wave of approach, is being more API friendly. So let's talk about what we mean in a little more detail here on each of these. So when it comes to being based on real traffic, I mentioned earlier that there are two kind of categories of traffic used in NPM. One synthetic, the other is passive monitoring of real traffic. And here the recommendation is that, synthetic test agents seem like a really good way to deal with these non-owned remote sort of resources, because you can't get in there necessarily and deploy your traditional hardware-based probes, but at least you can ping them, right? You can check to see if they're up. And that has its value, but really you need to find a way to get back to the real traffic, because the real traffic going to and from the resources that are part of your digital infrastructure, wherever they reside, is essential for understanding what the real actual performance is. Not just, can a test message make it through, but what's happening to all of the real production traffic that's moving back and forth to those resources. And when you have that data, it gives you the opportunity to do some correlations between that information, as viewed by the endpoint, wherever that endpoint might be, and the rest of the context of the traffic that's going on in the network and in the internet as a whole. So just to, not to totally diss the synthetic guys, because by the way, I've always been an advocate of a balanced approach. I believe you've got to have a little bit of everything to cover all of the bases you need. And there are still some values for synthetic. Synthetic in particular, really good if you want to make sure those resources are responsive and available, even when there's no real traffic going to them. So offers availability, really good to have. And then also, if you are fortunate enough to have very simple and repeatable transactions as part of the environment you're monitoring, you can realistically reproduce those and get a good proxy using synthetic. But there's definitely some limitations. You can't completely throw them out though. All right, next point. We want to talk about deployability and feasibility. Now, first, not all tools and technologies can be used in the new environment, but even with that said, and I just mentioned this, you're probably going to need some mix. You're going to have to think about using agents, even though to some people that's a dirty word. You're probably going to have to use some sensors. To other people, that's a dirty word. Go ahead, get dirty. You're going to have to use some mix to get your head around the complete environment and all of the potential viewpoints you need. One of the key things you got to realize, though, and this is, I think, a key point that I want to make sure is clear, traditional appliance-based approaches just aren't going to be enough on their own. So the big problem with these, appliance is extremely useful, very valuable for doing really, really deep packet-based inspection, but you have to get access to the packets. And that's just not practical when you're dealing with external cloud-based infrastructure. There are some adapted techniques to try to do this. None of them has found great favor. They all have limitations. But you may still want to have a traditional appliance back, on your side of the data center for your local environment in order to do the deeper troubleshooting when and if it's necessary. So you've got to go beyond just taking appliances. That just doesn't work anymore. So ultimately, you've got to be flexible with your approach here, but you've got to look at techniques and tools that are both very cost effective, because remember, I mentioned this earlier, the reason for moving to cloud and the reason for rebuilding, IT or backend infrastructure in a digital sort of manner is to save money. You are trying to be cost effective, and so you can't take an approach that's going to kill you from a cost perspective, licensing or operations. You got to find something that's cost effective. It's got to be easy to deploy too. I mean, really, the instrumentation and the methods you use for gathering performance metrics should be just as easy to deploy as the cloud resources are themselves. You've got to find ways to be cloud-like in the way you adapt here. And finally, it really needs to move with the workloads. Remember I mentioned earlier that dynamics problem. The things you want to keep an eye on won't necessarily be in the same place in an hour or a day from now. So the instrumentation approach, the strategy you use for gathering these metrics, needs to be able to float and stick with those workloads as they move around, or you'll lose visibility. All right, point number 3, Internet Path and Geo-aware. This is something that's becoming more and more important to a lot of organizations and was not necessarily part of the conversation, especially on the enterprise side. So it turns out that as you get into digital operations or you're using public cloud services, a lot of folks are getting to these or we're accessing them using the internet. If you've got digital operations and you're a digital business and your business is based on your customers reaching you across the internet, you have a huge, huge level of dependence on that internet connectivity being up and reliable and high performing. So you have to really start thinking about how do you get that view into the internet path between you and your cloud services or you and your customers, to a degree that in the past, most people were able to just sort of blissfully ignore it. So here's the reason why. The more hops that are taken between you, your resource, wherever it's being served from, is it your data center or is it in the cloud somewhere? The more hops, the more risk. Every time you take a hop, there's a potential increased latency, and so multiple hops. And even if you have a short number of hops, but you have a problem, you've got to think about alternative paths. And here's the reason: that not all paths across the internet, of course, not all paths are equal, and they do change regularly. So this is part of why internet routing protocols like BGP exist, is to handle and balance and try to optimize the traffic going across the internet for the greater good. Well, sometimes those optimizations work for most, but not for you. So this is why it starts to become really important in the age of digital operations to understand what's going on with these internet links. So without this, you are going to be at risk of not being able to be in control or optimizing customer experience, back again to one of those early objectives we talked about. All right, focal point number 4, cloud scale data analysis. Now, the point of this here is to look at the way that NPM solutions have been architected in the past. And NPM solutions absolutely can deal with tremendous volumes of information. It frankly is a big data problem in many ways, shapes, and forms. In the past, and most tools that are out there today do not have a big data architecture. Big data really can take care of some of the limitations that you have due to data management challenges. So without the big data architectures to keep all of the, the details, most systems will simply summarize and throw away those details. And then you're lacking the information you need to get to the bottom of problems. And you're lacking the visibility you need sometimes to understand what's real and what's not, what's valid traffic, what's not valid traffic to do your anomaly detection. So big data architectures definitely help with dealing with the volume of data and making it more flexible, but our experience is that a lot of folks have tried to build their own NPM adaptations using big data, but it's very expensive. It's expensive not necessarily from the cost of licenses, but it's expensive from the time and effort required to set up the big data backends, to figure out how to feed them data, and to figure out how to build reports and analyses against those big data backends. There are, though, tools that are coming along, Kentik is one of them, that are commercializing big data architectures. And that's where the answer is going to be in the long run. So finally, I mentioned this in the last slide, but I'm going to mention it again. This whole cloud scale concept offers an opportunity. It offers an opportunity to leverage cloud-based architectures in your tooling to deal with a cloud-sized problem that you have in your operating environment. So the cloud approach lets you access resources and solutions that can handle all the data without you having to do all the hard work and heavy lifting of building a back end that's going to do all that data management yourself. And it also makes it much easier to deploy these solutions. This is where SaaS comes in. SaaS is a cloud sort of architecture and strategy. If you can access your NPM as a SaaS, it solves you a lot of total cost of ownership pains. So the last focal point here, we're going to talk about API friendly. And the reason that I mention this is that APIs really are seeing tremendous adoption and use and getting increased attention and value around this whole move to cloud. We're changing our applications development environment, but we're now starting to have APIs be present in all aspects of cloud services and virtualization services. Whether you're virtualizing internally, making a private cloud, whether you're accessing Amazon Cloud Services, there's APIs now, and they get used most heavily to deal with the resources for setting them up and tearing them down and orchestrating and configuring. But increasingly, there is a need for figuring out how to leverage the same sort of API environment to get to the NPM data. And so the NPM data has not been well covered by the existing APIs out there. So this is really important, valuable information, not only the instance data, but also the performance data. You need to get access to this data, and your NPM system has to be able to support API integration so that you can feed the right data back to your digital operations and business decision-making processes. There's really important data in there that's contributory to both, customer experience, user experience, total activity. You can use this data to help you with billing decisions, with service activity and success, and product management decisions. It's all there. You've got to get that data back out of these systems. And the way to do that, we recommend, is through APIs. So what is Kentik doing about this? I've laid out some challenges. I've laid out some recommendations for how to deal with them. I want to give you a quick view of what's going on the Kentik side. Before I tell you specifically about NPM, let me just make sure you understand what we do. Our platform, the Kentik Detect service that we offer, is a software as a service. We draw data out of network infrastructure, as well as servers and agents and sensors. We put them into a multi-tenant backend, which can be also deployed on premises as needed. And then we run regular analytics against that. We run alerting against that. We run offline analytics for certain sorts of use cases. But ultimately, then we make that information available to multiple use groups within an organization. Network operations, network security, network planning and engineering, but also some of the data that comes from our system can be used to help make financial decisions, as well as to prospect for new sales. We have a number of service providers that are using our tools in just that way. Now, up in the upper left there, you see a little thing called NProbe, and that's what we're going to talk about today in terms of what Kentik has just announced. So last week, we announced availability, general availability of our NProbe host agent. And the NProbe host agent is an extension that Kentik is now making available to do true network performance monitoring metrics, to go above and beyond the traffic analytics that we've been doing to date, to now bring us some direct information about things like round trip times, retransmits, fragments, and out of order. This is based, by the way, harkening back to one of those priorities I mentioned. It's based on observing real traffic, which makes it extremely valuable, not only in giving you sort of a proxy, but actually telling you exactly what's going on for traffic going in and out of any particular host where you place these agents. Very flexible, support essentially all of the popular operating systems. You can put it on a server that's in the cloud or in your own data center. And that we have set it up to be optimized to send all that data to the Kentik Detect backend. Now, what that looks like from a diagram perspective, there's servers that can be any type of server, anything that's running any kind of function. We have folks who've deployed these on application servers as well as server, CPUs that are running functions like load balancing. Some of them can be on premises, they can be in the cloud, they can be wherever they need to be. They can actually, this agent can be included in, standard configuration for any nodes that are serving these purposes, and put into a Chef or a Puppet or an Ansible or a SaltStack sort of configuration, so that as you turn up more nodes, you can automatically turn up an agent with it. These agents actually look at the traffic that's going in and out of the NIC or the virtual NIC, depending on if it's a VM or a physical server, and calculates the performance metrics as well as just general flow activity, and then sends them to the Kentik backend through the internet with an optional encrypting agent in between if you want to encrypt that data to our Kentik Detect backend, where we then merge that data with all of the rest of the data that we are also gathering for each individual client environment. So commonly, this is also flow records, BGP data, geolocation data that comes from edge routers or backbone routers, or even sometimes east-west switches. We gather this data and collect it all into one common repository then that can be used for those multiple purposes I talked about earlier. So what does this look like? So within the Kentik portal, there's a few quick screenshots I'm going to share. If you look at the lower left corner, you'll see that the new metrics that we now make available for running charts and graphs against and for doing alerts against now include things like retransmits out of order, both count as well as percentage. We are also looking at round trip times, client, server, and application layer. So these are now metrics that are available for all of the functions within Kentik Detect. So for example, here's a dashboard built just to take advantage of some of this. It's showing a combination of latency measurements as well as retransmits. You can build these to track and understand what's going on with any of your important servers, your important services, anywhere you'd like to see a detailed view of the traffic going in and out, including not just volume of traffic, but also these performance measures. You can drill into any one of these. Here's an example from a real customer who is using this currently in production. And this is a view that they're looking at to understand percent retransmits. What this shows you is a case where there was a very high degree of retransmits. Collectively across several servers that they were monitoring, they were seeing as much as 10–15% total retransmit volume. So they figured out what some problems were in terms of configurations, were able to fix that, and you can see they were able to verify that they got down to a nominal level of retransmits after making some changes. So the one last thing I want to leave you with in terms of the success we're having here and the way this is being put to use is an example, a case study of one of the Kentik customers who's deployed this technology, how they've used it, and sort of what the results are. So this particular organization is an ad tech company. And for ad tech, it's really, really crucial that you serve advertisements quickly, efficiently. It's all about client retention and customer satisfaction. These companies are there. They're the ones that serve up all the ads that pop up Yes, I know, I'm sorry. This is the ad serving area, but it's really important, and then really, it's key technology, and it's key technology for a number of reasons. First, of course, it pays for a lot of the content that's out on the internet. That's how content providers can afford to gather content and present it to you, is by the revenue they get from the ads that they serve. Well, those ads have to be served quickly, and they have to be served efficiently. And so ad tech companies, and there's lots of them out there, make their business in doing exactly this, being the brokers for the content. But, interestingly, this now becomes a really important piece of the digital operations. If you are a content provider and you're using ad revenue, say, for instance, a good example would be Pandora. Pandora is switching their model slightly from subscription-based revenues to more ad-based revenues. Well, then they have an increasing reliance on those ad-based, content services being up, available very fast, very quick, highly reliable, or they'll lose their ad revenue. So it changes. As you move to a digital operations, if there's any sort of third-party content or third-party, element to your infrastructure, this becomes an important thing to keep an eye on. So back to the case study. The challenge here was that this organization understood that and recognized that they needed to keep a close eye on performance, but they also understood that there was a high reliance on the path that was being taken between, their systems where they're serving content and the downstream consumers of that content. And yet they were having a really difficult time figuring out where latencies were occurring. They could see that there were latencies at times, but they just couldn't figure out easily where it was without spending a lot of time trying to sort that out. So the answer, the Kentik approach that was applied, was to come in and start gathering flow data from the routers and from the nprobe host agent that was being deployed on both load balancer tier as well as the content servers. We're also then gathering passively BGP peer information or route information from the edge routers, and then correlating that. And what it allowed us to get to was a key performance indicator, or KPI, that we would describe as performance by path. So they're able to understand how each of the ad services were performing depending on the path that was being taken across the internet to reach the end target destination. So after putting this in place, now they had really a complete real-time view of this KPI that let them keep an eye on this, watch for changes, watch for when it got out of expected levels, and then actively go in and choose and manipulate the outbound paths of that traffic to try and find a better path. This is all being done manually today. They hope that they're going to automate in the future, but clearly it is a recognition of the fact that digital operations require you to have this combination of viewpoints and to connect it with what traditionally has not been a part of NPM solutions, which is understanding the actual internet path. So with that, I think we'll move to wrap up and takeaways. Just a few points to remember. Hopefully these points stuck with you. This is a new age. Cloud and digital operations change the landscape for how you're going to execute network performance management. The tools that are out there from years past are leaving gaps. They're not doing the job. You've got to rethink the tools that you're going to use. You have a new set of requirements. And there's a number of ways you can make sure that you're in the best position. Look for the real data that you can operate on and measure. Make sure that the techniques you're going to use are going to be viable in those cloud settings. Look for things that will give you that internet visibility, because that becomes an important part of your value chain. And then finally, look for tools that are ready to scale and can be integrated with the rest of your systems. Hopefully that stuck with you. Hopefully this was instructive. I'd like to hand it back over to Alex now for any questions that have come in.
All right, thanks, Jim. There are a couple of questions regarding the host agent specifically, so I'm going to kind of collate a few of those. Basically, the one question is asking about what version the host agent is. Is it new? Is it a version 1.0 product? Just, I think, trying to get an understanding for how mature that is.
Oh yeah, no, that's an excellent question. And it's called Kentik NProbe Host Agent specifically because this is the NProbe product, which we have licensed from an organization called NTOP. It's been in the market for years. It's a very stable, well-established product. It's got broad distribution. So we are not, just jumping in to the world of agentry and building agents that, that will do the job for us. We've gone and selected a proven field of technology, and that was an important part of our selection process.
Okay, great. The other main sort of angle of questions was how much the host agent costs.
Okay, another good question. So the way Kentik has structured this solution, there's no charge for the agent itself. The agent itself is free as part of the Kentik service. However, the way we charge for our service is by source devices in the flow that they're going to send us. So you would basically buy any generic flow license to accept data into our system, and then you can achieve that by sending it to us from a router or a switch or some other device that can generate flow itself, or from an NPM host agent if that's what you're trying to do.
Okay. There's one other major question here, which is whether or not Kentik supports application layer metrics.
Okay, good. So good question as well. I mentioned earlier on that it was important to try to tie these things together. Yes, in a way, we're looking at port protocol as the common way to identify, as well as combining that with the IP addresses or IP address range to identify applications and services distinctly. But watch this space, because we absolutely intend to add more capabilities over time. By the way, if you have a data source today, if you are using any sort of system that can add those sorts of details like HTTP address, we do now have, Kentik now has a custom dimensions feature that was recently launched that allows you to add that in and track that. So today we can take that in on a client-by-client configured basis. And we'll look at how to start doing that on a more systemic and standardized basis going forward. So watch the space. We'll be back talking about that soon.
And just to clarify what you mean by that, when you say custom dimension, how, if you have that data, how would you transmit that data to the Kentik Detect?
Okay. So the custom dimensions are a way for us to accept additional fields beyond the ones that we're already ingesting into our backend. So if you've got data fields coming in your flow records, your SFlow or NetFlow v9 or IPFix, that you would like to also track and keep within the system and add into all of the dashboards and the reports, all of the alerting functions, you can do that. It's an administrative configuration setting that you go into the Kentik Detect administrative portal, and you define which field it is that you'd like to keep. And today you can add multiple custom dimensions in that way, or custom data fields. So we've seen them used in a number of ways. We're just getting started with them. We're very excited to see how people put that to use. And like I said, we'll be back and report more on that. However, it has been shown and proven today that you can actually take HTTP URL information and put it in one of those dimensions, and then use that as a basis for alerting and reporting and pivoting and investigations.
Okay, so that's simple. So you're basically using flow record extensions, field extensions, to transport this, custom data, and what you're saying is that once that's in, it acts like any other field that we can operate on from an analytics point of view?
Absolutely, that's perfect, Alex.
Okay, good. It's just, it's funny because oftentimes we come from more traditional flow tools. You're used to custom data kind of getting dumped into some side table, and it's not really that usable. But in this case, we're really saying you can take custom data and really mainstream it into the full big data analytics that we offer.
Absolutely. It's designed to help, make that sort of what oftentimes would be an extended professional services engagement to do something like this. It makes it drop dead simple for folks to extend the platform and add new data fields.
All right, great. Well, that's it for our Q&A session. If you have further questions that you'd like that you think about later or are you're not ready to type into the chat window, the question and answer window here, you can contact us at info@kentik.com. You can come to our website and hit us up on the chat window there, and we'll do our best to answer you there on our homepage. With that, we're going to close this down, and I want to thank everyone for attending. Thanks, Jim, very much for your presentation. And we like to wish everyone a good rest of your day. Take care.